In this video, we're going to go over how to determine the mass concentration for a solution. So to begin with, we need the formula for coming up with the mass concentration for a solution. And so that is simply the mass of the solute. So the M here stands for mass, typically in grams, divided by the volume of the solution. So this is either in milliliters or centimeters cubed. So centimeters cubed is the same as milliliters, or in decimeters cubed, which is the same as liters. And so the way we represent the mass concentration is to use this Greek symbol here, rho. And so we would say that this is the mass concentration of the solute, or we would say rho subsolute for short. And so, like I said, the two most common units for mass concentration are going to be in grams per liter or grams per decimeter cubed, or grams per centimeter cubed, which is the same as grams per milliliter. So let's take a look at an example on how to calculate this. And so we're asked to calculate the mass concentration of sodium chloride in grams per decimeter cubed in a solution that's prepared by dissolving 3.60 grams of solid sodium chloride in water to make 25 centimeters cubed or milliliters of the final solution. Now, the first thing we need to note is we need the concentration in decimeters cubed, but we're given centimeters cubed. And so we need to know that there is 1,000 centimeters cubed in 1 decimeter cubed. Okay. So if we're going from centimeters cubed to decimeters cubed, we're dividing by 1,000. So 25.0 centimeters cubed is the same as 0.0250 decimeters cubed. Okay, now that we've done our conversion, we can set up our mass concentration. So the mass concentration of sodium chloride is going to equal to our mass of our solute. So our solute is 3.60 grams of sodium chloride divided by our total volume of our solution, which is the 0.0250 decimeters cubed. And if we do the math for this and note that both have 3 significant digits, our final answer is 144, and that's grams per decimeter cubed, or we can also write that as grams dm to the negative 3. Okay, so just two sort of ways that we can represent that final concentration. So that is mass concentration, pretty easy. That's it for this video. We'll see you in the next one.